Students, good morning. Really, I am so happy to continue my video through this CETEL YouTube channel. Today's class continues with the concept of diffusivity or diffusion coefficient. Diffusivity or diffusion coefficient. Diffusivity or diffusion coefficient is the diffusive mobility of component A in the solution. Diffusive mobility of A in solution in B. That is represented by the notation DAP. Diffusivity or diffusion coefficient is nothing but it is a measure of the diffusive mobility of A in solution in B. That is called as diffusion coefficient or diffusivity. It is the ratio of flux JA to its concentration gradient. So JA is equal to minus DAB into dou CA divided by dou Z. This is fixed first law of diffusion in the direction Z. Fixed first law of diffusion in one direction or Z direction. In one direction or Z direction. This law of diffusion is applicable in only one direction under steady state condition. Clear? So diffusivity or diffusion coefficient is nothing but it is a measure of diffusive mobility of component A in solution in B. Clear? It is a ratio of flux JA to its concentration gradient. JA stands for flux of A. This is concentration gradient. This is concentration gradient. I am already telling you that concentration gradient is nothing but concentration difference with respect to distance is called as concentration gradient. Flux JA is flux of component A. It represents characteristic nature of the component A in the solution. Clear? This is fixed first law of diffusion. This minus sign indicates decrease in concentration. Decrease in concentration. One important thing is diffusivity depends on the characteristic nature of the component A. Characteristic nature of component A. It depends on its environment, that means temperature, pressure, concentration, diffusion in liquids or gas or solid solution, also with characteristic nature of other components present in the solution. Nature of other components present in the solution. Clear? In order to discuss this information, let us consider a box. Let us consider a box. It is divided into two parts by using a partition. Just listen this figure. This is a rectangular wooden box. Consider this is a rectangular wooden box. This is divided into two parts. compartment 1, compartment 2 by a partition P, by a partition P. Clear? Initially, the partition P is located at the mid of this compartment. So area, volume and other informations are same on both compartment. Compartment 1, compartment 2, it is divided by a partition P. What I am trying to do is, I am going to take 100 kg of water in compartment 1 and 100 kg of ethanol in compartment 2. Clear? 100 kg water, 100 kg ethanol. 100 kg of water in compartment 1, 100 kg of ethanol in compartment 2. Listen carefully. Density of water is 1 kg per liter. Clear? If you are taking 100 kg water, its volume becomes 100 liter. So 100 kg, its volume becomes 100 liter. Clear? Density of ethanol is 0.79 kg per liter. If you are taking 0.79 kg, it occupies a volume of 1 liter. Are you clear? If you are taking 100 kg, its volume becomes 100 kg of ethanol, its volume becomes 126.6 liter. So volume of ethanol is more than the volume of water. Hence, the depth of the liquid will not be same. In order to provide the equal depth on both sides, the partition is adjusted towards left. This is second case. Second point, partition is adjusted, depths are equal. Clear? This is 100 kg water. This is 100 kg ethanol. Partition is adjusted, depth of the liquid are balanced. One important thing is volume is different but mass is constant. That is ensured by lifting this tray slightly and keeping a knife edge at the bottom. On both sides, mass gets balanced. The tray is at a position on the knife edge. Clear? Right. What I am trying to do is, I am going to remove the partition very carefully. Carefully without any disturbance, zero disturbance. What will happen? Provide as long as or sufficient time to this process. Once partition is removed, water will move to the right side for its diffusion, or water will diffuse into right side, or water will diffuse into ethanol. Similarly, ethanol will diffuse into right side, or ethanol will diffuse into water. So both the components will diffuse each other in order to ensure the formation of uniformity in concentration. At the end of the process or diffusion stops, what will happen? This tray, wooden tray, will be dipped in the right side. This is because the net movement of components to the right side. Originally it is balanced on the knife edge. Once partition is removed, after the diffusion is over, the tray will be tilted towards the right side. How it is possible? What is the calculation behind this? Okay, initially 100 kg plus 100 kg. So total will be 200 kg. This is 50 mass percentage. This is 50 mass percentage. A total of 100 kg in water, 100 kg in ethanol. Total will be 200. In this portion, mass percentage is 100 divided by 200. 100 divided by 200, hence 50%. This side 100 divided by 200, hence 50%. Again, I am going to perform the calculation on this 50 mass percentage basis. 50% means 50 kg water. Similarly, 50 kg ethanol. Okay. 50 kg water means 50 liter, its volume is 50 liter. 50 kg ethanol means its volume is 63.5 13.3 liter. A total of 113.3 liter. See, 113.3 liter contains 50 kg water. Already it contains 100 kg, 100 liter. If it is 100 liter, what about the amount of water? So 50 into 100 divided by 113.3. So near about 48.01, 44.08 kg. So after the diffusion is over, this side contains only 44.08 kg of water along with the 44.08 kg of ethanol. This side water is equal to 48.08. Similarly, ethanol is equal to 44.08 kg. So 88.16 kg in left hand side. Similarly, in the right hand side, 55.92. 55.92. The remaining thing is 111.84 kg. So what I am trying to say is net mass movement towards the right side. This is the diffusion characteristics of each compounds present in the process. Clear? Right. If right hand side movement to the right hand side is taken as positive, then Na is positive. Na is flux of A. If the movement in the right side is taken as positive, then flux A with respect to fixed location, with respect to this fixed location, Na is positive. Na is positive. Similarly, Nb is negative. Now I am going to write the total flux equation. Total flux equation. Total flux N is equal to Na plus Nb. Na is the flux of A in solution in B. Nb is the flux of B in solution in A. Now I am going to write the flux equation for component A. This is made up of two parts. One is flux by bulk motion. Flux by bulk motion. That means total into fraction. Total into fraction. That is XA into N. This is one more is diffusion process. Diffusion process. That means JA. So Na flux of A in solution in B. Na is equal to XA into N plus JA. Or I can write like this. Instead of N, XA into Na plus Nb minus of DAB into dou Ca divided by dou Z. This is the equation number 2.1 in your tribal mass transfer operations by tribal. This is the first stepping stone to enter into the mass transfer operation. This is the basic equation. Don't forget. Remember, this is the first equation, first stepping stone to enter into the mass transfer operations. This is equation number 1 in your tribal book, Na. Similarly, for component B, Nb. So this equation written like this: Xb Na plus Nb minus dBA into dou Cb divided by dou Z. On addition, for simplification, this equation becomes dAb into dou Ca divided by dou Z is equal to minus of dBA into dou Cb divided by dou Z. It indicates that flux Ja is equal to minus flux Jb. Clear? This is the base equation. This is the information regarding diffusivity and diffusion coefficient. Diffusivity or diffusion coefficient. Clear? Thank you.